Hardik M. Pandya, Research Scholar, Department of Mathematics, MK, Bhavnagar University, Bhavnagar. Topic Series Solution. Power series solution. We consider the homogeneous linear second order differential equation for y. Y is function of x. P0 of x into second derivative of y plus P1 of x into first derivative of y plus P2 of x into y is equal to 0, equation number 1, where coefficient P0 of x, P1 of x, P2 of x all are polynomials with no common factors. The value x is equal to x0 is called an ordinary point of equation 1 if P0 of x is not equal to 0. If P0 of x equal to 0, then x is equal to x0 is an singular point. Here ordinary points. If x0 is an ordinary point of equation 1, then it is possible to determine two power series solution for y centered at x is equal to x0. Example 1. Use power series to solve the second order differential equation. Second derivative of y plus y is equal to 0. Solution. We assume there is a solution of the form y is equal to power series c0 plus c1x plus c2x square plus c3x cube plus up to infinite is equal to summation form n is equal to 0 to infinite cn x raised to n. Now differentiate the power series term by term. First derivative of y is equal to derivative of c0 is equal to 0 because of c0 is constant plus c1 is constant. Derivative of x is equal to 1, so this term c1 plus c2 is constant and derivative of x square is equal to 2 into x plus c3 is constant and derivative of x cube is equal to 3x square plus up to infinite is equal to summation form, where summation n is equal to 1 to infinite n into cn into x raised to n minus 1. Now second derivative of y is equal to, here c1 is constant, so derivative 0 plus 2 is constant, c2 is constant and derivative of x is equal to 1, so here we get 2c2 plus 3 is constant, c3 is constant and derivative of x square is equal to 2x, 2 into 3 into c3 into x plus up to infinite is equal to summation of the form n is equal to 2 to infinite n into n minus 1 into cn into x raised to n minus 2, which is equation number 3. In order to compare the expression for y and y dash more easily, we rewrite second derivative of y as follow: summation n is equal to 0 to infinite n plus 2 into n plus 1 into cn plus 2 into x x raised to n. Equation number 4. Now substitute the value of y and second derivative of y. This uh, y is equal to this equation number 2 and second derivative of y, this value, we get summation n is equal to 0 to infinite n plus 2 into n plus 1 into cn plus 2 into x raised to n plus summation n is equal to 0 to infinite cn x raised to n is equal to 0. Now common out x raised to n both the term. So we get summation n is equal to 0 to infinite n plus 2 into n plus 1 into cn plus 2 plus cn into x raised to n is equal to 0, which is equation number 5. If two power series are equal, then the corresponding coefficient must be equal. Therefore, the coefficient of x raised to n in equation 5 must be 0, because 0 is the polynomial, 0 polynomial. So x raised to n coefficient 0. So n plus 2 into n plus 1 into cn plus 2 plus cn is equal to 0. Now value of cn plus 2 is equal to cn આ બાજુ આવશે એટલે માઇનસ થશે અને n plus 2 into n plus 1 denominator માં, where n is equal to 0 1 to infinite. Equation number 6. Equation number 6 is called a recurrence relation. If c0 and c1 are known, this equation allows us to determine the remaining coefficient by putting n is equal to 0, 1, 2, 3 up to infinite in equation number 6. Put n is equal to 0. n is equal to 0, we get c2 is equal to minus c0 upon 1 into 2. We get c2 is equal to minus c0 upon 1 into 2. Now put n is equal to 1. n is equal to 1 put करिए तो we get c3 is equal to minus c1 upon 2 into 3. Similarly, we put n is equal to 2, we get c4 is equal to minus c2 upon 3 into 4. But here we have value of c2. c2 is equal to minus c0 upon 1 into 2 minus minus plus c0 upon 1 into 2 into 3 into 4 is equal to c0 upon 4 factorial. Similarly, put the value n is equal to 3, we get c5 is equal to minus c3 upon 4 into 5 is equal to, the value of c3 is equal to minus c1 upon 2 into 3 is equal to minus minus plus c1 upon 2 into 3 into 4 into 5 is equal to c1 upon 5 factorial. Similarly, put the value of n is equal to 4, we get c6 is equal to minus c4 upon 5 into 6 is equal to minus c4, the value of c4 is equal to c0 upon 4 factorial minus c0 upon 4 factorial into 5 into 6 is equal to minus c0 upon 6 factorial. Similarly, put the value n is equal to 5, we get c7 is equal to minus c5 upon 6 into 7 is equal to minus c1 upon 5 factorial into 6 into 7 is equal to minus c1 upon 7 factorial. Now we see the pattern minus c2, c2, c4, so c0, c0. Now we see the pattern for the even coefficient c2n is equal to minus 1 raised to n into c0 upon 2n factorial. For the odd coefficient c2n plus 1 is equal to minus 1 raised to n c1 upon 2n plus 1 factorial. Putting this value into equation 2, we write the solution as y is equal to c0 plus c1 into x plus c2 into x square plus c3 into x cube plus c4 into x raised to 4 plus c5 into x raised to 5 plus up to infinite is equal to c0 into this plus c1 into this. This is even term and this is odd term, and this is a pattern of Maclaurin series of cos x, and this is a pattern of Maclaurin series of sin x. Here c0 and c1 are the constant, is equal to c0 summation n is equal to 0 to infinite minus 1 raised to n into x raised to 2n upon 2n factorial plus c1 summation n is equal to 0 to infinite minus 1 raised to n into x raised to 2n plus 1 upon 2n plus 1 factorial, where c1 and c0 are arbitrary constants. Put the value. This is the Maclaurin series of cos x and this is the Maclaurin series of sin x. So we get solution y is equal to c0 cos x plus c1 sin x. Now example number 2, double derivative of y minus 2x y dash plus 5 is equal to 0. We assume there is a solution of the form this power series y is equal to summation n is equal to 0 to infinite cn x raised to n. Now differentiating term by term, first derivative of y is equal to this summation n is equal to 1 to infinite n into cn is constant into x raised to n minus 1. The second derivative is equal to n is equal to 2 to infinite n into n minus 1 into cn x raised to n minus 2 is equal to this form n is equal to 0 to infinite n plus 2 into n plus 1 into cn plus 2 into x raised to n as in example 1. Substituting in the differential equation, we get this is the value of second derivative of y minus 2 into x into first derivative of y plus y is equal to 0. Summation n is equal to 0 to infinite n plus 2 into n plus 1 into cn plus 2 into x raised to n minus 2x summation n is equal to 1 to infinite n into Cn into x raised to n minus 1 plus summation n is equal to 0 to infinite Cn x raised to n is equal to 0. Here x raised to n into x raised to minus 1 and this is x raised to 1. So x raised to 1 minus 1 is equal to x raised to 0 is equal to 1. So here this term and minus 1. So this is cancel out. So this term is as it is. This term summation n is equal to 1 to infinite 2 into n 2 into n Cn is Cn into x raised to n plus summation n is equal to 0 to infinite Cn x raised to n is equal to 0. Now x raised to n x raised to n and x raised to n are common in all term. So x raised to n is common. So we get summation n is equal to 0 to infinite n plus 2 n plus 1 Cn plus 2 minus here minus 2n plus 1. So minus common लिए तो minus 2n minus 1 into Cn into x raised to n is equal to 0. This equation is true if the coefficient of x raised to n is 0. So we get n plus 2 into is equal to 0 into x raised to n. So n plus 2 into n plus 1 into Cn plus 2 minus 2n minus 1 into Cn is equal to 0. Minus plus is equal to so we get the value of Cn plus 2 is equal to 2n minus 1 into Cn upon n plus 1 into n plus 2 where n is equal to 0 1 to infinite. We solve this recurrence relation by putting n is equal to 0 1 to infinite successively in equation number 7. Put n is equal to 0, we get C2 is equal to minus 1 upon 1 into 2 into C0. Put n is equal to 1, we get C3 is equal to 1 upon 2 into 3 into C1. Similarly, put n is equal to 2, we get C4 is equal to 3 upon 3 into 4 into C2. The value of C2 is equal to minus 1 upon 1 into 2 into C0. So value of C2 is minus C0 upon 1 into 2 and 3 into 4 is equal to minus 3 upon 4 factorial into C0. Put the value of n is equal to 3, C5 is equal to 5 upon 4 into 3 into C3. The value of C3 is 1 upon 2 into 3 into C1 is equal to 1 into 5 upon 5 factorial into C1. Now again put n is equal to 4, we get C6 is equal to 7 upon 5 into 6 into C4. The value of C4 is equal to minus 3 upon 4 factorial into C0 is equal to minus 3 into 7 upon 6 factorial into C0. n is equal to 5, C7 is equal to 9 upon 6 into 7 into C5 is equal to, the value of C5 is equal to C1 into 1 into 5 upon 5 factorial is equal to 1 into 5 into 9 upon 7 factorial into C1. Similarly, put n is equal to 6, we get C8 is equal to minus 3 into 7 into 11 upon 8 factorial into C0. Similarly, put n is equal to 7, we get C9 is equal to 1 into 5 into 9 into 13 upon 9 factorial C1. In general, the even coefficients are given by even coefficient even coefficient C0 comma even coefficient C0 comma even coefficient in form C0 even coefficient in form C0, we get C2n is equal to minus 2 into 7 into 11 up to 4n minus 5 upon 2n factorial into C0, and the odd coefficient are in C1 form and 1 into 5 into 9 up to 4n minus 3 upon 2n plus 1 factorial. The solution is y is equal to C0 plus C1 into x plus C2 into x square plus C3 into x cube plus C4 into x raised to 4 plus up to infinite is equal to C0 form C0 into 1 minus 1 by 2 factorial plus x square minus 3 upon 4 factorial into x raised to 4 minus 3 into 7 upon 6 factorial into x raised to 6 minus 3 into 7 into 11 upon 8 factorial into x raised to 8 minus up to infinite plus c1 into x plus 1 upon 3 factorial into x cube plus 1 into 5 upon 5 factorial into x raised to 5 plus 1 into 5 into 9 upon 7 factorial into x raised to 7 plus 1 into 5 into 9 into 13 upon 9 factorial into x raised to 9 plus up to infinite. This is the summation form of the solution.